Good morning to all. The next topic is repeated root with symmetric matrices for a problem 2. Find the eigenvalue and eigenvector for the given matrices. The question has been given. Check the question first. Yes, it is a symmetric matrix. When you transpose the row into column A, transpose when you take it, we will be getting the same A. It is called as a symmetric matrix. Okay, we have to check whether it is a repeated root. First, I have written the characteristic equation. Determinant of A minus lambda I equal to 0. The determinant format. So, what is the equation? Shortcut. Lambda cube minus S1 into lambda squared plus S2 into lambda minus S3 equal to 0. Now find out your S1 and S2. We are going to find out what is your S1. S1 is nothing but sum of the diagonal elements. S1 is nothing but 2 plus 2 plus 2. So 6. S2, sum of the minor diagonal elements. 2 minus 1 minus 1 2 plus next diagonal elements 2 1 1 2. Last diagonal elements 2 minus 1 minus 1 2. Okay, when you simplify this, 4 minus 1, so 3, so 4 minus 1 3, so 4 minus 1 3, so it is 9. S3, determinant of A, calculate in calculator, will be getting the answer to be 4. So completed. So that you substitute lambda cube minus 6 lambda squared plus 9 lambda minus 4 equal to 0. Solve using a calculator or using a synthetic division. So now I will go with the synthetic division. 1 minus 6, 9 minus 4. Okay. So this variable 0, this you have to make it 0. I will solve for 1. 1. So 1. So minus 5 into 1 minus 5. So 4. 4 into 1 4 0. Yes, one of the eigenvalues 1. Other two eigenvalues you have to find using this equation. This you have to write it in equation format. Lambda square minus 5 lambda plus 4 equal to 0. So lambda minus 1 into lambda minus 4. Check it. Is lambda square minus 5 lambda plus 4. Okay. Lambda equal to 1, 1 and 4. So the eigenvalues are 1, 1 and 4 are the eigenvalues. Next step, what you have to do? For non-repeated, for a 4, first you have to find the eigenvector. For that, we will write it in a format of eigenvector. So eigenvector is nothing but A minus lambda I into x equal to 0. So it is nothing but 2 minus lambda minus 1, 1 minus 1, 2 minus lambda minus 1, 1 minus 1, 2 minus lambda into x1, x2, x3 equal to 0, 0, 0. First, what we have to do? Non-repeated eigenvalue first we have to find. When lambda equal to 4. Okay. Substitute lambda equal to 4. In this, I'll get the equation to be minus 2, minus 1, 1, minus 1, minus 2, minus 1, 1, minus 1, minus 2 into x1, x2, x3 equal to 0, 0, 0. Okay. Now you check two different equation you have. Yes, all are three different equation only. So write any two equation and solve by cross multiplication rule. The first equation, second equation, and third equation. I'm going to take only the first two equations for cross multiplication rule. So, cross multiplication rule. So, x1 minus x2, x3. So, x1 means don't consider x1 remaining in the determinant format. Minus 1, 1, minus 2, minus 1. x2 minus 2, 1, minus 1, minus 1. x3 minus 2, minus 1, minus 1, minus 2. So, simplify this. 1 plus 2, so 3. Here 2 plus 1, 3. Here 4 minus 1, 3. So, commonly divided by 3. So, my vector will be, my first vector will be 1 minus 1, 1. Here, this minus symbol. Okay. So, first vector completed. Second vector, same way lambda equal to 1, you take it. Lambda equal to 1 when I take it, I'll be getting the matters to be 1. Okay, so lambda equal to 1 means 1 minus 1, 1. Here minus 1, 1 if I put means it is 1. Here I'll be getting minus 1. Here 1, minus 1, 1. So all the three equations are same. So it's nothing but x1 minus x2 plus x3 equal to 0. Only one set of equation because all three are same. Same equation, writing so many things, it's not necessary. Okay. So now put any one variable equal to 0. x1 0 means x2 equal to x3 is nothing but k. K equal to 1 means I will be getting x2 equal to 1, x3 equal to 1. So my second vector will be this is my second vector 0, 1, 1 is my second vector. Two vectors completed. Third vector, you should not take any one variable 0 and put third vector. That is wrong. It is like type 2. Okay. It can be applied for non-symmetric only. We know that A is symmetric. The given question A is symmetric means if A is symmetric means orthogonal condition satisfied. Okay. Your eigenvector orthogonal condition satisfies. So therefore, okay, the x1, the first vector transpose into the new vector, whatever I am going to calculate it, is 0. Same with the second transpose into x3 equal to 0. So that is why x1 transpose means x1 transpose, what is here matrices? It's nothing but 1 minus 1, 1. Okay. So x3 is nothing but A, B, C equal to 0. One set of equations. Same way here 0, 1, 1 into A, B, C equal to 0. So it's nothing but two equations. So that you write it. So when I write it, A minus B plus C equal to 0. 0a plus b plus c equal to 0. Now by cross multiplication rule. So by cross multiplication rule. So when you apply it, a by minus b by c by. So a it's minus 1 and 1 1 1, b 1 1 0 1, minus 1 minus 1, so minus 2 1 1. So my third vector now I am getting to be minus 2 minus 1 1 is my third vector, or 2, okay, 1 minus 1, any one answer. So this is our third vector. So all the three types